While most games use dice that are shaped like cubes, some games use a gaming die that can be modeled using an octahedron. Yeah, see? Told you there was a die that looked like that. A solid that has 8 equilateral triangular faces. You can use the sketch to explore how to approximate the surface area and volume of the die. So the surface area, that's going to be the area of each of those triangles on the faces. And then the volume is going to be how much can fit inside of the object. So press triangle to model a face of the die with a triangle. Use the information provided to complete the exercises below the sketch. All right, so we've got our triangle here. The triangle is I guess that's as good as it's going to get. So the triangle is 1.38 along the sides and 1.18 for the height, and the area is 0.80. How can you calculate the surface area of the octahedron without using a formula? Well, if you find the area of this guy, which they told us right there what it was, we take that area and we multiply it by how many of those there are, which they told us there was 8. We can figure out that we're going to go 0.80 times 8, and that's going to give us the surface area for our object, right? 0.80 times 8 is 6.4. And we're on in centimeters. Right, because we know that the area of one of the triangles is 0.80, and there's 8 of those triangles total. And that would work with any of your polyhedrons. If you know the area of one of the faces and you know how many of those faces exist, you can figure it out. What is the surface area of the die? 6.4 centimeters squared. Right? Anytime you have area, know that you have a unit squared. Can you separate the octahedron into 2 congruent polyhedra for which you know the formulas for the surface area and volume? Explain. Yeah, you can find the volume of just the top part. You can find the volume of just the bottom part and add them together to get the volume for the whole thing. You can also, excuse me, find the surface area of just the top. You can find the surface area of just the bottom and add them together to get the surface area of the whole thing. Because this square that we see here kind of cuts this into 2 figures, 2 rectangular pyramids. You can think of this as a rectangular pyramid or a square shaped pyramid, whichever one works the best for you. And then use the measurements found in the sketch to label the octahedron. Okay, so we got to go back up because I don't have them memorized. All right. So the side length was 1.36. So that's this. And this. The height was 1.16. Whoa, go back. And then this height here, they didn't give to us specifically, but if we know that this entire distance is 1.36, and we know that from this point to the edge is going to be half of that. So this is going to be 0.68. We know that this is 1.16, so we can figure out this missing piece here, because 0.68 squared plus the question mark squared has to equal 1.16 squared by way of the Pythagorean theorem. 0.68 squared is 0.4624. 1.16 squared is 1.3456. We'll subtract the 0.4624. We get that the question mark squared is 0.8832. You take the square root of that, and you get the question mark is 0.9397871, so 0.94. And then use the basic formulas provided to find the volume of the die. Because I'm trying to record this, it's not loading properly. So let me go back here. The volume of a regular prism is a 1/3 the area of the base times the height. So the area of the base is going to be 1.36 squared. And we're going to multiply that by the height, which is 0.94. And then we're going to take 1/3 of that, multiply by 1/3. And that gives us 0.574. 0.95, so 0.60. The top. We're doing the whole thing, aren't we? Yes, we want to do the whole thing. So we need 2 of those actually. So we're going to multiply that by 2. So we'll get 1.159, which is 1.16. And we are in centimeters, and it's volume, so it's going to be cubed. Volume is always cubed. Alrighty. Questions on that?